Woo! Okay, so we're going to talk about a really cool thing. I like it. It's called binomial expansion. It's what happens if I take a binomial. A binomial is like an a plus b or a 2x minus 5 or any of those type of things, and we raise it to a power, and we got to multiply it out. So it's like foiling, just big term type thing to go with that. Now, here's what the thing is. I've already talked to you a little bit about this. If you happen to watch all the videos way back in the probability unit, had you done that, you would have seen this little chart in there, and I talk about how these things are all related, and that's going to be extremely important that you get this. So I would strongly recommend going back and looking at the probability unit lesson 1, the extras, because I talk about this pattern in there. I see you're going to use it. So now let's talk about what binomial expansion is. According to the theorem, it is possible to expand. See if I can make this bigger so you can read it better. According to the theorem, it is possible to expand any power of x plus y into a sum of the form yada 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 yada. Something I need to bring out here, and it's just because it's the way it's written. This little thing here is just a notation about how to find the coefficient on each of these terms. And we'll talk about how to figure that out. And it's called the binomial coefficient. It's what that's referred to. That's what each of those work in. So we can take anything, x plus y to the nth power, and we can figure it out. Now notice they have some ways to do this. Let's see if I can get this to pop a little bit. Ooh, there we go. Not too bad. So if I have x plus, or 1 plus x to the nth, I would have this type of a series going on right here. Or I could write it in the sigma notation, and notice that's in there too. So here's something you can get written down if you want all the information. But let's just get on to the good stuff here with this. Okay, so what we're looking at is we're going to be asked to expand, wrong pen. They want us to expand. I don't want that as a magic pen anymore. Put that back there. Expand each of these things. Well, here's the thing we know. Anything to the 0 power, no matter what it is, always becomes 1. Anything to the 1 first power is always just that thing. So I just get x plus y. Now, anything to the 2nd power says I should take it times itself. So I'd have to take x plus y times x plus y, which means I've got a FOIL. So I've got to take the x times the x and get an x squared. I got to take the x times the y and get an xy. I got to take the y times the x and get an xy. I got to take the y times the y and get a y squared. So when I clean this up, I get x squared plus 2xy plus y squared when I multiply it out. Same thing that we've done before. Now, if I was going to do x plus y to the 3rd power, I would take x plus y times x plus y times x plus y, which means these first two are just this one. So I would have x squared plus 2xy plus y squared that I'd have to multiply by an x plus y. And when I do that, I end up with this when I get it all cleaned out. And then if I did the 4th power, I would take the x plus y times the x plus y times the x plus y times x plus y and multiply it out, and I would get the one that's there. So here are like all these x plus y's all the way up to the 7th power. Now here's a really neat thing, and this is kind of where I was talking about in that other video. If I just look at the coefficients here, no. If I look at each of these, there's certain things to notice that come up. First thing to notice what happens to the x. The x starts with the power, and it goes down. Each exponent on the x goes down until we get to x to the 0, or we get a 1. And it always starts with the same power. So notice when this was a x plus y to the 3rd, I got an x to the 3rd. X plus y to the 4th, I had an x to the 4th. The 5th, the 5th. It always starts with that one, and it goes down. Now the next thing to notice is what happens to the y. The powers of the y start at 0. Notice there's no y term here with the x to the 7th because a y to the 0 is 1, so I want to put it down. And then it keeps going up until I get to the 1 with the 7. So the first one start going down, the second one start going up, starting at 0. Okay? The nth row of Pascal's triangle will be the coefficients of the expanded binomial. Huh? What does that mean? That means if I look at Pascal's triangle right here, this is row 0, row 1, row 2, row 3. I just have to find where this number is. If that's the exponent, that row is going to give me the coefficients in a fashion that is something I could use. Take a look how these numbers look just at the numbers when we look back up here. We had a 1. We have a 1 and a 1. We've got a 1, a 2, and a 1. We've got a 1, a 3, a 3, a 1. A 1, a 4, a 6, a 4, a 1. If we go back here, we have all those numbers, same numbers. This Pascal triangles gives us those coefficients. Okay, so then the next rule here, for each line, the number of products, i.e. the sum of the coefficients, is equal to 2 to the nth power. And for each line, the number of products is equal to n plus 1. This is probably, these are the 3 that I really, or 4 that I really like. That one there, and I guess that would be right. If I add up this number and 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 this number, I would get 2 to the 7th power if I add them all up. That's what that one is saying. That one I don't, yes, it's true. Okay, so here's the thing. Back here, we're given a formula on how to do this. And it says we have to use this little thing right here to figure out what that coefficient is. That little thing right there is the combination of n things taken n minus 1 times at a time. It is an NCR. Every one of these, this is an NC0, NC1, NC2. Every one of those is an NCR. It's a combination. It goes back to that stuff from probability. Okay, so I've talked all this through. What does it mean for you in the assignment? You're going to see something like this. Expand each power. They want us to find this. They want us to multiply this out. So this one here, here what I notice. I notice it's a 5th. So I could go to Pascal's triangle and look in the triangle for the 1, 5, on and on and on and on, and use it. I also know right off the bat, it's going to be a p to the 5th. And then I know it's going to be a p to the 4th, and then a q. And then a p to the 3rd, and then a q squared. And then a p to the 2nd, and a q to the 3rd. And a p to the 4, or a p, and a q to the 4th. And then a q to the 5th. Now the one thing I always like to note, that I point out to people, is notice the sum of the exponents. If I look at the exponents and I look at the sum, this q really has a 1. This p back here really has a 1. Those are always the same exponent there. Okay, now all I need now are, what are the coefficients? So I know it's 1. I know it's 5. I know it's 10. 10, 5, and then I would have my plus signs right there. So my answer is p to the 5th plus 5p to the 4th, q plus 10p to the 3rd, q squared plus 10p to the 2nd, q to the 3rd, plus 5p, q to the 4th, plus q to the 5th. And it's because I know my Pascal triangle. You got it down, it's a piece of cake. If you don't have it down, well then this one right here is a combination of 5, 0. This one right here is a combination of 5, 1. This one right here is combination of 5, 2. This one right here is a combination of 5, 3. Now, something to note on this particular part, how this second value in each of those matches the value of the corresponding Q spots. That's very important to know. Okay, let's look at the next problem. T plus 2 to the 6th. Well, we automatically know what's going to happen here. It has to be a t to the 6th, and then a t to the 5th, and a 2, and a t to the 4th, and a 2 goes to the 2nd power, and a t to the 3rd, and the 2 goes to the 3rd power, and then a t to the 2nd, and the t2 goes to the 4th, and then a t, and the 2 goes to the 5th, and then I would have a 2 to the 6th right at the very end. Now, I don't have the coefficients in here, so I could go back to Pascal's triangle and find the row for the 6, or I could take the combination of 6 things taken whatever at a time. And here I would get a 1, and here I'm going to get a 6, and here I'm going to get a 15, and then I'm going to get a 20, and then I'm going to get a 15, and then I'm going to get a 6, and then I'm going to get 1 in front of the 2 to the 6th. Now, with this one, I'm not done now, because I have these spots where I have multiple numbers in each term. I need to deal with those. So when I do that, I get a t to the 6th here, and 6 times 2 gives me a 12. So I get a 12 t to the 5th. And now I have a 2 squared times 15. 2 squared is 4 times 15 is 60. Now I have a 2 cubed times 20. 2 cubed is 8 times 20 is 160. Now I have a t to the 4th. Well, t to the 4th is 16. 16 times 15 is 240. Now I have a t to the 5th, which is 32 times 6, which is 192. Now I have a t to the 6th, which is a 64. So that's my answer when I don't have two variables, but I have a variable and a number, and I have to work it out that way. Now let's look at the next one down here. This one's quite a bit more challenging because I got to think of this as x plus a negative 3y to the 4th. So I got to think of the negative 3 together as being my second term. So I automatically know, once again, it's going to be an x to the 4th. And then it's going to be an x cubed, and then the negative 3y gets to go to the first power. And then I know it's going to be an x squared, and the negative 3y gets to become squared. And then I know it's going to be an x, I should put my pluses in here, x, and the negative 3y gets to go to the third power. And then I know it's going to be a negative 3y to the 4th power. But again, I need to know what are the numbers here. What are the binomial coefficients? What are the numbers in Pascal's triangle that matches the 4? Well, that's a 1, 4, 6, 4, and 1. Right out of Pascal's triangle. Or, once again, we can take the combination of 4, comma, and then which term are we doing? 1, 2, 3, 4, or 5. There's always one more than that. Okay, so now let's clean this one up. X to the 4th, good. Here, notice I have a 4 and a negative 3, so that gives me a negative 12 x cubed plus, possibly, now I have a negative 3 squared times 6. Negative 3 squared is a positive 9 times 6 gets me a 54. And then I have the next one. Now I have a negative 3 to the 3rd, which is a negative 3 times a negative 3 times a negative 3, which is a negative 127 times 4 gets me a negative 108. And the x, oh, I forgot my y here. And the y is now cubed. And now in the last term, I've got 1 times a negative 3 to the 4th power. Well, a negative 3 to the 4th power is a positive 81, y to the 4th. Now notice what's happened. I forgot a couple of y's. The x's started at the 4, same power. They went down. The y's started at 0. They went up. And I had to deal with the numbers with the y getting raised to the power and then multiplying by the number out in front. All that has to work together. Okay, I know I'm starting to run long here on time. But the last thing that you're going to have to be able to do is to figure out a certain term of a expansion. I want the fourth term of a plus b to the 8th. I want to know what is the fifth term of 2a plus 3b to the 10th. The way we do this is we know it's going to have to go down. With 8 as an exponent, that means I actually have 9 different things. Let's take a look back up here just for a quick second. When I had the first term, notice there's no y's in this one. Let me bring that back into the magic pen. Okay, so when I look at the first term, there we go. First term, there's no x's. First term has nothing, so the y value is 0. The second term, I had a y. Can I make this bigger? There we go. I had a y. I had a y, and it was to the first power. The third term, the y was to the second. The fourth term, the y was to the third. The fifth term, the y is to the fourth. So notice the second variable, this one here, is always one less than what term I'm looking at. So if I'm looking for the fourth term, I want the b to be to the third power. And then I can have the a. And then I can have the coefficient out in front. Now to figure out the coefficient out in front, I can go running through the whole rigmarole. Otherwise, I can just know that it's going to be the combination of 8, comma, well, what's the power on the b? 3. So a combination of 8 things taken 3 at a time is going to give me my binomial coefficient. I've got to figure out the exponent on the a yet, and that goes back to the little rule I was talking about at the top of this page. Right here, notice how all the yellows added up to be the exponent. So since my as an 8, this would have to be a 5. Now all I need to know is what is the combination of 8 things taken 3 at a time. Combination of 8 things taken 3 at a time is 56. So I get 56, a to the 5th, b to the 3rd. So again, the thing to note here, the term number minus 1 gets you the exponent on the second part. That same number gets used in the combination to figure out what the coefficient is. So let's look at this next one. We have the fifth term, which means the 3b has to go to the fourth power. The 2a with its exponent and the 4 have to give me a 10, so this has to be 6. And my little coefficient part here, oh, yeah, there we go, is going to be a c, 10 items taken. I use the same exponent as what's on the second term, the 4. So if I take the combination of 10 things 4 at a time, 10, math, get to that NCR, I'm going to do a 4. I get 210 times. Well, now in here, I got to take the 2 to the 6th power. Well, I've already told you that was 64. And then I have an a to the 6th. And now I also have a 3 to the 4th power. 3 to the 4th power is 81. B to the 4th power. Now I want to multiply all my numbers. 210 times 64 times 81. And I get 1,088,640. 1,088,640. A to the 6th, B to the 4th. And that's how we find a certain term. We go back and we use the combination from the stuff before. We use Pascal's triangle, which we talked about in that last unit. So when I go to expand a binomial, like any of these, I could physically work it out like you did in Algebra 1. Do the FOIL process like we have sitting right here. That's just doing the FOIL. Or doing the FOIL and having to do more than the FOIL to get to our final answer. Or you can use these shortcuts. It's up to you now. Good to go.